So normally one line diagrams are made on per unit representation basis, so that everything is in a single line, in a transmission line, as we have discussed about the power system supply, that which we have discussed in the previous class, that the representation of a power supply was in a block diagram way. So that was a block diagram way. So another way is the representation of the same by the one line diagram, or that is also called as the impedance diagram. So how to represent the, or how to make a impedance diagram? How to make the impedance diagram? So first of all, the selection of the base voltage and volt ampere ratings are necessary. The first thing is the selection of the base voltage and VA. The second thing, which very much important, that once you have selected the VA rating, that will be the constant for whole system. So the base VA will be same. Second, base VA will be same for the whole system. The third thing about the base voltage, the base voltage changes according to the transformer, and if the transformer is coming, then the new base will be equal to the old base multiplied by the line to line voltage of the transformer. So this was the thing for the base value, VS VA will be same. So now coming to third point, which is very much important. Since base VA is, once you have selected the base voltage and base VA rating, then it will be same for the whole system. No issues with that, and one can do that. But coming to the base voltage, please understand this thing very clearly, that base voltages are not same for the whole system. Once a transformer is coming in between, the base voltage changes according to the transformer, and it is like the base voltage will be new base voltage will be, or I can say that new VD will be equals to old VB multiplied by line to line voltage of transformer. This is a very important point in changing of a base from one base voltage to another base voltage, that is new VB, but when a transformer comes. This thing happens because of a transformer. This thing happens because of a transformer is coming in between a line. Suppose there is a generator, then the tie lines, and a transformer is coming, then the load, like this. So for the whole system, as we have discussed in this, for whole system, VA will be same. From here to here, the VA rating will be same. There will not be any change. Since this is a generator, this is a transformer, this is a transformer line, or I can say transmission line XL, it's a bigger XL. So don't get confused, X stands for transmission, L for line. The transmission line, this whole thing is a transmission line. So this is kind of a one line diagram which I have made right now. Everything is in a single line and everything is in series right now. we can have another generator connected over here. This is also a single line diagram. So when I convert this thing into the reactances, or we can say that impedance, so that will be a impedance diagram. So the impedance of everything is collectively written in a or drawn in the same place, and that is called the impedance diagram. We know all these things, not to go into that deeply. But the thing which is very much important here is that understanding of the change of base from one place to another. So here, when I am going from here to here, the generator base would be changed according to the SB what we have taken, VA, the selected VA we have taken. So I will be finding VA, new VA or new Z per unit on this basis, for this also. For this, here, the transformer ratio will come over here. Suppose 1:n. So according to that, here VA rating, so here voltage rating would be the same. V old base rating will be here, and here after the transformer, V base new will come. And again, if another transformer is coming, so from here to here, VB new will come, and from here VB1 new will come. So according to our transformer, base voltage changes. Here it was old, then it came to new, then now the new will become old for the same thing, and VB new, again a new VB1 will come after a transformer. So n number of transformer will be coming, so n number of VB will be coming, new VB will be coming. So that is the way we are describing a impedance diagram over here. So we can have a question on the selection of the bases on the new bases. So we can start with a smaller example in which there is a three-phase synchronous generator giving a power, some voltage is given, the impedance of the line is given, so we have to determine the voltage drop in the line in per units. And in all volts also, the reference bases are already given in the question. So we can have the question now. So we can have an example to understand this thing better. The example is like a three-phase synchronous generator delivers 10 MVA. MVA at a voltage of 10.5 kilovolt. The line impedance is given as 5 ohm. The line impedance is given as 5 ohm. So we have to find that voltage drop in per unit and in volts. So the reference bases which have been given in the use reference base as 12 MVA and 11 kilovolt. And 11 kilovolt. So if we do this question directly, it's very easy that the SB is given and this is the voltage, so we can find the current, and from the current and since the impedance is given 5 ohm, so current into this will be the voltage drop in the line. So that is very easy to understand. We can do that in the way, the normal way which we are doing till now. We can have that. We can have the quick look on that. So SB is given as 10 MVA. Right now I am doing this question on without the base. So I am forgetting about the reference basis, anything. Nothing is there. So SB is given as 10 MV and the voltage V is given as V is given as 10.5 kV kilovolt. So I can have the current. So since it's a 3-phase, so S will be equal to under root 3 into VL into IL. Okay. So IL will be coming as S is already given 10 into 10 raised to the power 6 divided by 10.5 into 10 raised to the power 3 into under root of 3. So this would be the current IL line current, that is coming as 549.86 amperes, 549.86 amperes. So I can have voltage drop. So voltage drop would be equals to IL into Z. That is equals to IL is given as 549 into Z is given as 5. So approximately this answer is coming as 2749.3. 2749.3 amperes. Volts. So we can write this answer, that is 2749.3 volts. This is the voltage drop which we are getting by a normal procedure which we have done, which we know till now. So I can do the same problem on the reference base also. How? Since SB is given as now, this is SB, and this is VB. So I can have the per unit values of everything, and that per unit value will be multiplied by something, and that will be giving me the answer. The same way I will be doing on the per unit also. So I can have the V per unit right now. V per unit will be like the 10.5 divided by, this is the actual value of the voltage, and the base value of VB is 11 kilovolt. So this would be, we will not solve this thing, we will solve it. And I can have the S per unit also. The S per unit is the actual value of the MVA rating is given as 10 MVA, that is 10 into 10 raised to the power 6 divided by, it's given as 12 into 10 raised to the power 6, which is equals to 10 by 12. So I can have the Z per unit also, and the S per unit also and V per unit also. So in the same way I can have I per unit also. I per unit would be SB upon VB, or I per unit will be SB per unit upon V per unit. S per unit is given as 10 into 12 multiplied by, everything will be coming over here, into 11 by 10.5. So I can have the per unit value of the current as 0.873. So this will be coming, I per unit will be coming as 0.873. This is the current. So again I can find the Z per unit now. Z per unit for this will be equal to the 5 Z ohm multiplied by SB upon VB square. So the Z per unit on the new base, which will be 12 MVA and this one is 5 multiplied by SB is 12 and BB is 10.5 square. Sorry, this is 11. This is 11 now, not 10.5. This is the base value which we will be choosing as 12 and 11. So this would be coming as approximately as 0.4958. So this is as coming as 0.4958. So I can have I per unit already came as this 0.873. I will write over here and commit this thing. E per unit I will commit. So and Z per unit I got at 0.4958. So I can have voltage drop in per unit right now, which will be equals to this multiplied by my 0.873, 0.4958 multiplied by 0.873, which is actually coming as 0.4329. 0.4329 almost. So that is in per unit. So this is the per unit drop which I will be getting in the line. So I can convert this thing into my volts also, which we have already discussed, but we will see whether this is coming equivalent to that or not. So this is 0.4973 in volts. So V in volts will be equals to 0.4329 multiplied by my actual value, that is 11,000 kilovolts. That is 11. This is the base which I have chosen. So if I do this thing, if I solve this thing, this will be almost coming as 2749.3. 2749.3 volts. So we can see this thing, that this thing V volts from the procedure of reference base is also equivalent to the same thing which we got previously by the direct way also. So these two ways which we have seen are the same. So the values which we are getting in per units, if we multiply by the base value, we will get the actual value. So we can see this thing, that this is coming in points, I per unit was in points and Z per unit was in points. So when all these things are in points, the value which will be getting in a very large system will be maximum by 10, 20, not more than that. So the value which we will be getting in not more than 10, so we can compute them by hand also. So there will not be any requirement of calculators, there will not be requirement of the PCs to calculate or to compute the voltage ratings or to the current ratings or to the KVA ratings, anything. So since all the things, all the values are very less, so we can compute them by manual method also without any use of computers and calculators. So rather than choosing all the things in 10.5 kilovolts, then 11 kilovolts, 12 MVA, we can have smaller values and we can compute them by manual method also. So computation is very much easy by unit representation. So this is the way we are doing some per unit representation. We can have another example on the same per unit representation. So we have to do something over here, so which we have discussed in the impedance diagram. So this is a question on making of a impedance diagram. It is example number 4, I suppose. So this question was based on the track of making impedance diagram or impedance diagram, or one line diagram is given to you. You have to find the generated voltage of a generator. Suppose that there is a generator over here. It is connected to a transmission line. The full transmission line is given here, and this is the 210 kilovolt bar is given, and a load is given as RL as 500 ohm. This generator is there, and this transmission line is actually connected by a transformer which is of 50 MVA and 15. This is of 50 MVA and 15 kilovolt to 220 volts. And this generator is of 75 MVA and the voltage rating is 15 kilovolt again. And the XG, the reactance of the generator reactance, is given as 0.75. The XT, the transformer reactance or transformer impedance, is given as 0.1 per unit. The transmission line also is given as XL is equals to 100 ohm per phase. So we have to determine the generated voltage per phase. We have to determine the generated voltage per phase. So how to start with this question?